months. I'll just start with mentioning a few points before we get into it. First of all, please bear with us. We are conducting these webinars over the WebEx platform. So if you're facing any technical issues, first suggestion is to please try and reconnect and see how that's going. I assume everyone can hear me nice and loud and clear. During these webinars, we will open the floor at the end of the session for question and answers. If you can all later or during the course of the presentation type into the chat box, there is a special field for Q&A, and feel free to put your questions in there and we'll address them towards the end. What I would like to start off with is a brief introduction in terms of our speaker today. So first of all, my name is Kamal Rashid. I look after the EV charging segment for us in Asia Pacific and looking after the solutions. And our presenter today is Wim Elshout, who is the sales manager for the e-mobility solutions on a global level. This webinar series is in this environment with everyone or most people working from home. We figured it's a good opportunity to be able to have a digital solution where people can come and connect, and we can share some of the trends, technology, and solutions that ABB is deploying across the world. What you see in this slide here is our planned events over the next few months, the first of which will be talking about the trends in the automotive and electric sector. We will be going through in each webinar will be running for about 40 to 45 minutes. So we do want to cover various topics throughout the sessions. Starting with the overall trends, we will go into product portfolio overview, being able to identify the exact electrical and e-mobility solutions for your requirements, the general use cases. We will be introducing some new products across these webinar series, given the current scenarios. I think this is a very practical step that we can achieve. We will be looking through our digital solutions, more importance about how you can manage your networks, how you can look after your charging solutions from full electrification scope as well, and then sharing more details in terms of specific applications, whether it is high power charging, the latest technology we have, and the heavy vehicle solutions. So without further ado, I will pass over to Wim, our speaker for today. Thank you, Wim.
Yeah, also from my end, a warm welcome to all of you, and thanks very much for participating in this first of 5 webinars that we will be doing over or maybe even 6 I saw on the list over the coming months. And a warm welcome for you to participate in this webinar under the special conditions I think that we're all working under these days. I think most of us will be working from home. I hope you're all healthy and your beloved ones are healthy. And once again, appreciate very much that you're attending this webinar today. The webinar will be on the trends in the automotive and electrical sector. And prior to starting the webinar, I would like to start off with a picture of these two gentlemen. I'll give you some time to look at them. You may recognize them or not. But these two gentlemen are actually Thomas Edison and Henry Ford, 2 pioneers when it comes down to the electrical and the automotive sector. And what you may not know, is there still no sound? Camille, can you let me know?
No, it's fine.
Okay, good. So what you may not know is that these two gentlemen in the early 1900s were close friends. In fact, Thomas Edison was working for Henry Ford prior to his move out of the company and to start his own electrical company. And together they developed already in the early 1900s an electric car together. And that was called the Ford E. There has been prototypes. There is spy pics, like we still see some spy pics today on the cars that are coming to the market. But unfortunately, the Ford E failed to be successful and actually was never released and brought to the market. So fortunately, today, as somehow of a contribution to these two gentlemen, I was very happy a couple of months ago when Ford announced to bring their iconic car, the Ford Mustang, to the market in an electric version. Now, what these two gentlemen were working on in their early 1900s is exactly what I want to cover in today's presentation. I would like to discuss the merging automotive and electrical sector today. What I want to do prior to starting with that presentation is to give you a short introduction of ABB. As ABB, we are the global market leader in fast charging of electric vehicles, and we do that globally. We have supplied more than 13,000 DC fast charging stations around the globe in more than 81 countries. And we are supplying our DC fast chargers to various segments in the market. We are supplying them to the early charge point operators. We are supplying them to the utility companies, oil and gas companies, and very important as well is the automotive industry that we are working closely together with. Because we work so close with our customers and with the automotive industry, we've been able to get a close look and an insight in the developments that are taking place in the automotive industry. And what I want to do is, before taking you through the disruptive trends in the electric sector, I would like to take you through some of the trends that we see in the automotive sector today. And these disruptive trends in the automotive industry are being also called the ACEs, the acronym for the 4 trends that are globally being recognized as the trends that currently, so to say, keep the CEOs in automotive industry awake at night. One of the first trends that we see is the electrification of the vehicles. If we look at the various graphs and predictions that exist from the various consultant companies, we all know that there is the acceleration of the e-mobility market and so to say the hockey stick that is predicting a certain number of cars on the road by 2030 or by 2040 or so. And I think all these graphs do convince us that e-mobility is developing fast and that it is there to stay. But for me, one of the most interesting graphs that I've seen over the last few months, and that is once again a good proof for me to show the market that e-mobility is evolving fast and that it is there to stay, is the graph that you see over here. It is a graph that shows the various electric vehicle models that we've seen on the market in Europe since 2012 and that are announced to be released until the year of 2025. And if you look at this graph, what you see is that the year of 2020 is really the year that the big change will take place. Now, we all know that under the current circumstances with the coronavirus, that may have a slight delay, but that is, as somebody recently told me, probably just a dent in the acceleration of the e-mobility uptake. But what we see here in this graph is that by the year of 2012, we only had the option to pick from 8 models that were available on the market by then. That grew to 22 or so in 2018, 2019. And this year, it is predicted that if we listen to the car OEMs, that more than 70 models will be available to pick from, and that will even grow further to 175 models by 2025. Now, that taken into account, together with the price of the batteries that is going down, and the energy density that is growing within the vehicles, we can predict that around the year of 2024, that it is predicted that the price of an electric vehicle will be on par with the traditional internal combustion engine cars, or so to say, the ICE cars. But if you look at this trend, you see some other stats as well in here. In 2025, and again, we're now trying to look at the trends in the automotive industry. It is predicted that the electric vehicle production in 2025 will be 6 times as big as that it was in 2019. Um, 4 million electric vehicles will be produced in 2025. That is approximately 20% of the total European car production capacity. 60% in 2025, 60% of the EVs will be full electric EVs, and the remaining 40% will be the plug-in hybrid electric vehicles. And that also needs to say, and we also need to take into account and look at the alternatives that exist, but it is predicted that by 2025, only a small portion of the vehicles will be fuel cells, and less than 1% will be based on CNG, LPG. Now, if we look at what is all driving this, of course, that is all driven by the global CO2 reduction that is taking place, and driven by the authorities in various countries around the world. And some of the authorities have also committed to it by taking part in the 30 by 30 initiative. That's an initiative joined by several countries around the world to have a reduction of 30% of the CO2 emissions by 2030. And of course, we also need to take into account and to see what's going to happen with what is currently going on with the corona situation, or the COVID-19 situation, that actually we think will also drive a further uptake of e-mobility. We may be stalling at the moment a little bit, or the evolution may be stalling a little bit, but in the end, we all think it will further grow. So that is about the electrification of the vehicles. Another trend that we should recognize that exists is that more and more cars will become autonomous. If we look at a somewhat older report from McKinsey, but still very valid, is where we see two scenarios being described. Two scenarios. One of them is a high disruption scenario, looking at autonomous vehicles that are fully autonomous or conditionally autonomous, and a more negative scenario, or a low disruption scenario, also for the conditionally and fully autonomous vehicles. If we look at this graph, and if we first take a look at the positive or the high disruption scenario, positive is all relative, of course, but what is predicted is that the tech players will start introducing their fully autonomous vehicles around 2025. And the mass market leaders, so to say the traditional car OEMs, will start doing that as predicted slightly later than that, somewhere between 2025 and 2030. And it will be somewhere slightly after 2030 when the popular consumer models will be introduced to the market. So if we look at the high disruption scenario, it is highly predictable and highly to be expected that by the year of 2040, 90%, which might be slightly high, of the vehicles on the road will be fully autonomous. Can you imagine that we are not driving ourselves anymore, but that the car is in full control by then? Of course, there's also some barriers that will be in place that might slow it down. These barriers then slow the introduction of the vehicles down by a few years. So then the introduction will not be by 2025, but then somewhere after 2030. And of course, what may happen as well is that there might be some incidents that will have an effect as well on the publicity around all this, and that may affect a slower uptake of the autonomous vehicles. Now, all in all, what we can conclude that by 2040, if we look at this graph from McKinsey, and if we go and sit somewhere in the middle of these two scenarios, that we can expect that approximately 50% of all vehicles is expected to be autonomous, fully autonomous by 2040. So cars will be electric, cars will become autonomous, and that leads us to the last two trends, which I like to combine together, and those are the trends where all the cars will be connected, and where cars will be shared. They are somehow interrelated, and that's why I've grouped them together. Now, if you look at the autonomous, connected, electrification, and the shared as well, you do understand the disruptive acronym of ACES for the automotive industry. If we look at the connectivity of the vehicles, and if we look at car sharing, then it's interesting to look at this graph from McKinsey. Also, McKinsey predicting, if we look at the car revenues or car sales revenues, we see that the growth from 2015 to 2030 is predicted to be an average of 2%. And that is mainly driven by the growth in the emerging markets. It could actually well be that in the mature markets, the car sales will decrease. Yeah? But as an average, by 2030, the global car sales market will have grown with 2%. And of course, if the market grows, also the aftermarket grows as well. But what's very interesting to see is that if we look at a market that hardly existed in 2015, but that has grown significantly by 2030, that is the market that is related to shared mobility. That is car sharing or the e-hailing services from companies like Grab in Asia and Uber and Lyft in other places of the world. And then, of course, there is the data connectivity of the vehicles, where apps and remote services, etc., will be part of as well. Now, what's interesting to see is that it is predicted that the growth of the car sales is not as big as that new business that will play such an important role in the years to come. So besides of the two trends that we have already identified, we need to take into account the other two trends as well, and that is the connectivity of the vehicles and the car sharing. Now, if we look at these trends and we take a step back and see what the impact is on the market, then I've listed these trends or the impact of the trends in this slide. And if we come to a conclusion here, is that less people will own a vehicle in the far future, but the vehicles will still be there, but the utilization of these vehicles will be much higher. That means that there will be more vehicles. That there will be less vehicles doing more kilometers or a higher mileage. And that there will be less vehicles, but that they will spend more time driving on the road. And that means that they are less time parked. And that is important if we start to link this to the electrical sector. That means that if we have these disruptive trends, that we really need to take a careful look at the charging services that are being offered, because the charging service should always match the charging demand. Yeah? So what we see is that charging at home is there to stay. I mean, private ownership will still be there of the vehicles, and people will still be charging their vehicles at their houses. But there will be more and more depot and public charging places or plazas where cars will be charged, and they then need to be charged fast because with the high utilization of the vehicles, there will be only a short period of time for these cars to be charged. Now, as ABB, we also look at these charging demands, and we see how we can match our products with the charging demands. Now, we recognize that there are 4 types of market demands when it comes down to charging. And all these demands are based upon how long do you spend on a location. And then we recognize that there is a segment where you spend 12 hours or so, or between 4 to 16 hours, which is normally places like your house or at work. And then there will be locations where you spend 1 to 3 hours or so. That could well be for a business meeting. It could be for a nice dinner somewhere or a shopping mall. Yeah? And you would like to charge your vehicle on these locations. Then there are locations where you have some convenience around the charging, so that you can charge your vehicle, but in the same time you can do your groceries, or that you can enjoy some fast food. And then, of course, the last segment is the segment where you want to spend as little time as possible, and that is on the highway at the service station, where you want to charge your car as fast as possible. Now, we have our products developed for these to match these 4 segments. We have an AC charger to be installed at the locations that are suitable for a charging between 4 to 16 hours. We have a DC wall box. That is what you would like to use when AC is not sufficient anymore to charge your car within the time frame of 1 to 3 hours. And the DC wall box can charge your car with 20 kilowatts. Then there is the segment of 15 to 60 minutes of charging, which originally was a segment of a 50 kilowatt charger. That is now evolving to a segment where cars can charge with 50 to 100 kilowatts. And then there is the product line with the high power fast chargers that can charge between 150 to 350 kilowatts. I'm getting feedback again that somebody cannot hear me. So if that is common for everybody, please let me know.
No, you're fine. It's just individual issues.
Okay, good. The 4 products that match the charging, to support the customers with the charging demand that they have. And I can talk for hours about this slide, and we will do so, but not today. We will cover these products in the webinars that are to be organized or that will be organized over the coming months. So more details on these individual products in the months to come. Now that we are getting close between now that we are bringing the automotive sector and the electrical sector together, we also have to take a look at the trends and the disruptive trends in the electrical sector. And that is where we see not the ACEs that we see on the automotive sector, but we also have an acronym, believe it or not, for the electrical sector and the disruptive trends over there. And that is what we call the 3D disruptive trends. And what we see in the electrical sector, what currently is taking place is the digitization of the technology. So all the technology will be digitized and will be connected. There is a high decentralization where maybe not currently, but maybe yesterday, our infrastructure was based upon a central power generation and an infrastructure for distribution. Today we have really decentralized power generation and a lot of microgrids popping up around the globe. And then there is the decarbonization of the energy that is being produced at the moment, or so to say, the green energy. Now, what I would like to do in a small case that I'm going to describe here is to show you how these 2 sectors are coming together. And I want to do that with an example of a charging site that needs to be connected to the grid, and where chargers and other consumers and producers will be installed. Now, if we look at the charging site, of course, what we need to do is we need to bring in a substation to connect the chargers, to be able to connect the chargers to the grid. And for the sake of this example, I will take away that box. Otherwise, there gets too many lines on this slide. And to the substation, we can connect our chargers. For the sake of this example, It doesn't really matter whether these chargers are AC chargers, DC wall boxes, high power fast chargers, or maybe even the chargers for heavy vehicles that can charge up to 600 kilowatts. It doesn't really matter. We can charge all type of vehicles with the chargers, whether that is passenger cars, it can be trucks, or it can be buses. Now, to bring in the trends in the automotive industry, you already see one trend over here, and that is that cars will be electrified. Yeah. But the other trend, and let's not forget about that, is where the cars would be connected, where the cars would be autonomous, and where the cars would be shared. Yeah. So these four trends are all coming together here on this picture. We see that cars. This could also apply to a car sharing program where multiple cars are being brought to a site for a charging session. These cars could be autonomous as well, where they need to have an automated connection as well between the charger and the vehicle. That is currently something and the development that is taking place for passenger cars, but it is already a development that is available in the industrial market for trucks in various industries. So cars are being charged, and what we then, of course, if this is the charging site, that is a very basic charging site. Now, taking the full electric disruptive trends into this picture as well, of course, we have to add the decarbonization and the decentralization as well of the electrical sector. So we could add battery energy storage to a charging site as well, and of course we could add other producers, green producers, to the site as well. Solar panels, wind turbines would be applicable for a site as well. And then, of course, you will have a building on a charging site. And the building could be a small service station, but it could also be a complete depot where a whole fleet of buses or trucks is being managed. So looking at this picture, we have now taken into account almost all the trends that we see in the market. One thing that we forget and that we need to add to this picture for the trends in the electrical sector is the digitization and the availability of the data to connect that to some smart decision support systems that can support us with forecasting of energy production, for fleet management, or maybe to efficiently and to optimize the energy costs. Now, this is an ideal picture of a charging site, but how can this be managed? To show you how ABB manages these type of scenarios, the various scenarios that we see here, I want to take you through 3 scenarios that we recognize that exist and that we have currently installed in the market. First of all, it is if we look at the scenario where we go to a charging site and the charging site has a battery energy storage available as well, because the charging site could have a too little grid connection and it needs battery energy storage to compensate for the power that is not available from the grid. This scenario is what we call the don't blow the fuse. How do we now manage that these chargers and the battery can all work together and staying within the requirements and the available power from the grid? We can simply do that by connecting all the chargers and the battery to the local site controller and to the substation, and that we can manage the chargers. Now, this is a scenario that we have installed for Europe's biggest charge point operator that is installing high power fast chargers on a site besides highways, but where the grid connection is not sufficient. So that is where we are supplying a battery energy storage system in combination with the chargers, and based on the connection to a local site controller, we are able to derate the chargers when it is required to meet the grid connection, or where we let the battery energy storage kick in at the moment that it is required to support the chargers, or that we allow the battery energy storage system to be charged when the energy is available to do so. The second scenario that we can do is if we include all the other producers and consumers on site as well. So now we are not on a highway location anymore where we have high power chargers installed, but now we could have a site where buses are being charged, a bus depot. A bus depot with chargers, with a battery energy storage system, but maybe also with solar panels installed, could be wind as well. But of course there will also be a building or other operation that is consuming energy on the location. What we then can do is we can again link all these producers and consumers to a local site controller, and the local site controller then will manage the distribution of the power amongst these consumers and include the battery energy storage and the solar panels to meet and to stay within the grid connection. This is what we call the site load management scenario. And of course, I'm talking about a local site controller. What we also can do, of course, is to all link this to a router and make that available on the cloud, so that the data can be accessed remotely as well, and that you also can control these scenarios remotely. So you don't necessarily need to do that on site. You can do that remotely as well. Now, these two scenarios we have installed for the charge point operator in Europe, and one for a bus terminal in Germany. And what we are currently now entering is the last but not least scenario, and that is where we really would like to make use of the big data that is available, and that is also coming from this site, and that can be combined with smart systems that are available. Now, then we would need to link the smart systems that are available to the cloud environment, so that we can really start using these predictive tools to support the users with the operation that they are running. And then we can include tools like the forecasting of the energy that is going to be produced, or we can introduce fleet management tools, so that we can look at prioritization of vehicles, or that we can help vehicles with the best route that they should take. Or of course we can look at optimizing the energy costs that are involved. Now, I think the business case for these three scenarios is crystal clear. The first two business cases are really linked to how can you make use of a maximum number of chargers, or how can you charge a maximum number of vehicles, taking into account the grid connection that you have and the other producers and consumers that you have. And then you have to realize that if you can reduce the grid connection, or if you don't need to upgrade your grid connection, that can have a significant saving in the investments to be made for charging sites. But not only on the investment, because there's also a significant operational cost involved in the grid connections. So if you can reduce, or if you can avoid to upgrade the grid connections, there's a significant gain for you that justifies the business case for these type of scenarios. And of course, if you look at the more intelligent-based load management, yeah, that is where you can really use the tools, the smart tools that are available to further optimize the investments that that need to be made, and to further optimize the operation that you are running. Whether the operation is for public charging or for industrial charging, then doesn't really matter. It is really an optimization of the investment and the operation of the charging locations. Now, this brings me to the end of this half an hour webinar. And this picture shows clearly how the trends in the automotive industry, that's what I started with, are being linked with the trends that we see in the electrical sector. And then I must say that I'm proud, if I bring these two gentlemen up again, that I'm proud that we are currently achieving what they were already thinking of in the early 1900s. And I think that's a small token of appreciation from our side that they have been the pioneers and we are currently making it happen. Thank you very much for your attendance during the last 35 minutes. And now I think I'm going to give the word to Kumail to open up a short Q&A.
Thanks, Wim, for that. Yes, we've already had some questions come through, which I will read out for you to answer. And if anyone else has any other questions, feel free to put it in the Q&A box in the chat window that's there. Okay, the first question we have, Wim, is do you have any figures, predictions in percentage home charging versus public charging?
Oof, no, I don't have these. I don't have these numbers. I can only say that from my best guess. But if we look at what is currently happening on the market, is that the majority of the charging will be done on locations where you spend most of your time. And that could well be 90 to 95% of the charging will be done at home or at your office, at your working place. But that means we cannot leave the fast charging services or the range extension services that are so critical for the drivers to be able to meet their requirements to travel long distance, that we cannot leave that untouched. So most of the charging, say that 90 to 95%, will be done at home. And but for the e-mobility sector really to pick up and to grow further, we also need these range extensions on the locations as I have just discussed them. Now, what we also need to take into account is that 90–95% may drop in the long term a little bit when we really go into car sharing, when we go into autonomous vehicles, etc. Then we will see more these cluster areas or these depots where car sharing programs will be charging their vehicles and so on. So 90 to 95% right now. But my prediction is that in the long term, that number will reduce a little bit.
Thank you. And similar lead on, but in terms of the installed base figures that you showed earlier, could you give an indication of, say, roughly how many are for commercial vehicles, such as buses, and within that, how many of those chargers come with some kind of automatic charging connection, like a pantograph?
No, these numbers I do not have here at hand, but I can share you what's happening on the market at the moment. We've seen the uptake of the automated connection for buses since the last 3 years. That was when we started to install the first pantographs to connect to a bus, to charge the bus at those days at 150 kilowatt. Today we can do it at 600 kilowatt. If we look at the numbers that we've seen of the 13,000 plus that we've installed around the world, I think that currently we have installed 2,500 of these chargers to be heavy vehicle chargers. So say 2,500 out of the 13,500 chargers are for heavy vehicles. And then the remaining 11,000 are for passenger cars. And what we see is a variety of automated connection devices. We see, of course, the pantograph that is commonly used in Northwest Europe or in Europe, I can say. In other places around the globe where buses do have bigger battery capacities and top-ups are not really required during the service of the bus, people use overnight charging. So if we look at these 2,500 chargers I think that we have installed for heavy vehicles, I think 40%, 30 to 40% are with automated connection devices, and the other 60 to 70% are connector-based charging for heavy vehicles. Now, sorry for touch once more on that, on the automated connection devices. We see the pantographs coming in, pantographs that go down, so that are mounted on the infrastructure. We see also a trend, and we see that being 50-50, where we see the pantograph being mounted on the bus. So that means that the pantograph will connect from the bus to the infrastructure, so to say. And ABB serves both technologies. We see in the industrial environment where there's no space for pantographs, we see a certain type of pin coming in. We are currently supplying that to automated guided vehicles in a harbor environment, where we are charging the AGVs that pick up containers and move them from one location to another location. And then what is currently happening within the passenger cars, so what is currently happening in the passenger car market is that within SHARIN, SHARIN is the body that is defining the CCS standard, and it's collaboration of the car OEMs, the technology suppliers, CPOs, and other participants. That is where we are currently defining a standard for the automated connection for passenger vehicles as well. Yeah, that to say on installed base and automated connection devices come out.
Perfect, thank you. Then another question: are the systems that ABB is developing for the three scenarios using open access architecture and protocols? Let's say the scenarios would be the different segments.
Yeah, no, absolutely. If we look at the local management of the scenarios, we are using open industry standards for the communication between the chargers or other consumers and the producers. So it's a very commonly industrial standard that we use. It's an open standard. It's not proprietary ABB. So that is all possible. Of course, when we start talking about linking the smart systems to the big data environment, then we get more into proprietary systems. But linking the consumers and the producers to a local site controller and making that available to manage remotely is all being done by open, I would almost say, industry standards that we are using. What we have done is we've worked closely together within ABB with our division that is specialized in the industry and that is taking care of the automation of the industry. And we are using their tools to connect these producers and consumers to a local site controller and to manage it all from there. So open industry standards.
Great. And a similar topic along the technology side of things. Is ABB looking to develop any dynamic charging for electric vehicles? I think it's broad. Yeah, I think it's a very broad question.
By dynamic,
I guess it's about power sharing, load sharing.
What we are currently having is a system where we have power cabinets, but again, we will touch on that in the product portfolio discussion in the next webinar. But I can touch on that now. Our current architecture is based upon a power cabinet that is having a maximum capacity of 175 kilowatts, and you can double, and then you can link that to a dispenser or to a charge post. You can double the capacity by simply adding a power cabinet to it, and then you have at the dispenser 350 kilowatt available. And yes, we do support dynamically sharing of the power available as well, because you could add another dispenser to it, and then you have either 350 kilowatt available on one dispenser or 175 kilowatt available on both dispensers. So that is what we dynamically do.
Great. A question targeted towards the automakers. Do you see automakers readily embracing high power charging solutions, or are we still some way from mass market passenger EVs being able to charge at 350 kilowatts?
350 maybe a little bit far away from being a common technology to be brought to the market. But if we look at what is currently happening on the market, is that we see the energy density coming to a level where the range of the vehicle gets long enough. So we see now cars coming to the market with a range of 350 to 400 kilometers. Now, if you would practically translate that in Europe would mean 4 hours of driving. And having lived in Asia myself for a long time, 400 kilometers in Asia can take forever, but can take many hours. What I'm trying to say here is after these 4 hours, you need a break anyways, whether you're traveling in Europe or whether you're traveling in other places in the world. And that is the moment where you want to charge a vehicle. What you want to happen at that stage is that you can charge a vehicle as fast as possible. So what I see changing these days is that consumers of vehicles are looking at the range of the vehicle, which they recognize is now getting to a level that they can practically accept it. Of course, they are used to their petrol car, which can do 1,000 kilometers, but they're starting to accept the 400 kilometers as they realize that they would need to charge it by that moment. But then, if they charge it after these 4 hours, they would like to charge it as fast as they can. So charging speed becomes extremely important. And we now see more and more cars coming to the market where 50 kilowatt was the standard of the cars coming to the market a year ago. Today we see cars coming to the market that are somewhere between the 50 and 100 kilowatts. And we will go to the situation where the cars will be charging at 100 kilowatts and then have different options to choose from to make that 150 and even higher charging capacity. So yes, I do predict that the car manufacturers will bring vehicles to the market with a range that we think is sufficient, but also that we can pick from various charging speed options, so to say, charging capacity options.
Perfect. Thank you for that. There are, just as a general address, there are many more questions, which unfortunately I wasn't able to choose from. I did skip quite a few questions on the technology side, because what we will plan to do is address these questions in the subsequent webinars coming forward, specifically on things like load management, vehicle to grid, energy storage systems, and then the technology between each chargers. In fact, Wim, if you don't mind skipping straight to the second slide, I believe. I'll just do a quick recap of the upcoming webinars. I really do appreciate everyone's support and joining this webinar. Here is a list of what we are planning to do going forward. The dates are booked in, and you will get a registration link for each of these events. The order may be subject to change, but basically these are the general topics, and we will be more than happy to accommodate your questions during these other webinars. So Wim, I'll give you a last word if you'd like to say, and then we can wrap up.
Yeah, no, thank you very much, Kumail. Thanks for facilitating this webinar. It all started a couple of weeks back with a webinar that we were targeting on Asia Pacific. But it's funny because it showed that we were a little bit short-sighted, Kumail, you and me, when we were starting to organize this. Because when you organize a webinar, it's on the World Wide Web and it's not really linked to any region anymore. So in this webinar, we had more than 500 participants. Spreading from Europe all the way to Australia. So thank you very much for participating in this webinar. And very important these days, a message from me personally to you all: please stay safe, follow the instructions from your authorities, and let's make sure we can get this whole e-mobility world up and running again as soon as possible. So thanks very much for joining, and hope to see you again. No, not to see. Well, I hope to see you again as well, but hope to talk to you again on May 14. Thank you very much, and goodbye.
Brilliant. Thanks, Wim. And yes, just to answer those other last questions, the recording and slides will be shared going forward, including this presentation. Thank you, everybody. Take care.